Okay, hello, assalamualaikum warahmatullahi wabarakatuh. Okay, hello everyone. Here I will continue my explanation about Newton's law, especially maybe for 11 ICC2 because we haven't uh, discussed anything about the materials of Newton's law. Yeah, especially for the every laws in Newton. Okay, let's start. Okay, the first one is the law of inertia. Okay, let's start with the term inertia itself. Okay, inertia in a simple way, it means laziness, laziness, or kemalasan, right? Okay, here we have a law of inertia that said an object will remain at rest, okay, will remain at rest, which is the velocity will always constant or the object doesn't move, okay, and a moving object will keep traveling at a constant velocity, okay, at rest or constant velocity unless acted upon by an external net force, okay. An external net force, it can be represented by the sum of F here, okay? And the condition that makes it become in inertia condition, that is this one, okay? The object will remain at rest, and the second one, the object will move in a constant velocity, okay? So the key points is two. The first one is the velocity is zero or constant, and the second, the acceleration will always be zero or based on the material we have already discussed earlier, that is the uniform linear motion. That is the topic we have already discussed about. Okay, for the formula itself, yeah, this is the formula we will have for the first law of Newton or the law of inertia. That is sum of F or the net force, every force that acting on the object. Yeah, if we sum all of the force, so it will be equal to zero. Okay, which is sigma F itself is a sum of all forces acting on an object, and it's the unit of sigma F is N or kilogram meter per second squared. Okay, like this. Yeah. Okay. Firstly, I want to introduce you also about the free body diagram. A free body diagram. Okay, free body diagram itself is a way for us to draw every force that acting on the system. Okay, the first one for drawing a free body diagram, so we have to state or define the x and the y-axis. Okay, let's say if the object moves upward, so it's directed y, okay, in y-axis. Then if the object moves in horizontal direction, so it means that the object moves in x direction, okay? So because in the law of inertia, in this case, the object is doesn't move, so it will just come up with the weight force, yeah, which is we know that the weight force is equal to m times g, okay, and g itself is the gravity acceleration. Yeah, maybe for the common one is 10 meter per second squared. Then after we have a mass or an object that interact with the surface, so as we have already discussed earlier, it will result a normal force that coming upward like this. Okay, so based on the formula of the law of inertia, that sigma f is equal to 0. So because here we have the force that acting on the object or the system is just directed in y-axis, so we're just focused on the y-axis here. So sigma Fy equals 0. Sigma Fy itself, it will be equal to N minus W. Okay, normal force subtracted by the weight force. Yeah, why the weight force is minus it? Because it's opposite from the normal force. Okay, so we will have that N equals W, and it's equal to m times g. Okay, so when we want to know also about the value of normal force, so we can just time the mass with the g, or the gravity acceleration. Okay, see? Okay, let's move to the second law, that is the law of motion. So simply, you can find that every object or every system that state in a motion condition, yeah, or when the object is moving with an acceleration, so it can be defined by the second law of Newton. Okay, that said, the acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. Okay, simply, um, it means that an object will accelerate more when a greater force is applied and less if it has more mass. Okay, so here we have the formula based on the law that we have already read before. Okay, and firstly, the key points of this law, that when the object moves with an acceleration, as I've said before, this law is a load. Okay, and the formula for this law is sigma f equals m times a. M itself is the mass of the object, and a is an acceleration. And sigma f is the same as before. That is the sum of all forces that acting on the object, yeah, which has unit Newton, or kilogram meter per second squared. Okay, let's say here we have the same object. Okay, this is a block which has mass m kilogram. Okay, let's say that we push, yeah, with a force here. Okay, this is an external force. Then of course we will know that oh yeah, for by the way, firstly we have to make a free body diagram, which started by assuming the axis, yeah, that exists in this simulation. Okay, like this, and we have an external force that acting on the object like this. We push the blocks like this. Then, as usual, we are already know uh, that there is a weight force here. Then there will be also a normal force. Then, because for the x-axis force, it only has a F force, or an external force, yeah. So because there's no a resistance, yeah, for the motion itself, so the object will moves with an acceleration. Okay, when we want to know about the acceleration value, so we can use the law of motion formula. Sigma f equals m times a. Okay, for example, okay, let's say that we have the mass of the object is equal to 5 kilogram, then the gravity acceleration still 10 meter per second squared. Then for the external force that we give to the block is Let's say this is 5 Newton. Okay, so the question is, what is the acceleration? Okay, so we can use simply the this formula, sigma f equals m times a. Sigma f is just f, yeah, because we're only consider the x direction motion, yeah, so we just x. Okay, so the sigma fx is just f. It's due to the force that acting on the x-axis is just external force here. Okay, so F will be equal to m times a. Okay, F itself is equal to 5. M is 5 kilogram. Then for the a itself, it will be equals to 1 meter per second squared. Okay, so this is the acceleration for the motion of the block, which has mass 5 kilogram here. Okay, that's simple. Okay, and we can look at the mass, yeah, based on the previous explanation, that an object will accelerate more when a greater force is applied, but less if it has more mass. So the mass itself, when we have a higher mass, so the acceleration for the block will be lesser. Okay? Yeah, let's say maybe we can just assume that the mass is 10 kilograms, so we can just input to the same formula, so we will have the acceleration will be half meter per second squared. Okay. Okay, everyone, that's next to the third law, that is the law of action and reaction. Okay, firstly, we can see or look at the picture on the right side here, that there is a man pushing against a wall like this. We can assume that a man giving an action force or F1 to the right side of the wall. I'm sorry, the left side of the wall, yeah, like this. And the wall, we can assume that the wall give a reaction force that is F2, that which has opposite direction. Yeah. So in this third law, yeah, or the law of action and reaction, it told us that every action force is met with a reaction force that is equal in magnitude but opposite in direction. Okay. And the key points here, the force always come in pairs. Same magnitude, opposite in direction. Same magnitude, opposite in direction. So, for the formula is equal to F action equals minus F reaction. And the note is, for the minus sign here, it shows the direction of the reaction force. Yeah, so actually for the magnitude itself will be the same, but for the direction will be different because of there's a minus sign here. Okay, and actually, for the other example, yeah, except this example, we can look at the phenomenon when there is a dropping down of an object to the earth. Okay, let's say that this is an earth. Okay, as we all know that there will be a gravitational force that acting on both object, that is the earth and the mass, yeah, or the blocks here. And actually, for the block, yeah, it will give, yeah, the weight force, yeah, as we know that weight force is actually equal to gravitational force, yeah. Then the earth will directed opposite, but in the same magnitude. So this is W accent. Okay, so in this case, the reaction force is W and the action force is W and the reaction force is minus W accent. Okay, I guess it's wrong, yeah, for me for the illustration because the length of the vector is really different. Yeah, actually it should be the same. Okay, I guess that's all for the um, explanation of three laws in Newtons. Yeah, I hope you can get the point of the materials. If you have any questions, you can just ask me at the class meeting. Okay, see you. Maybe we can continue to discuss about the exercise or the example. Sorry, it's not exercise, but examples. See you.